Today we're going to go over using tables to represent equivalent ratios and how you can use a table to solve for missing information. So these are your notes in your Schoology folder as well. I'm just going to work through them with you. Alright, so we have a ratio table. We're given a lot of information and we have some missing information. There are lots of different strategies you can use to find that missing information, so we're going to work through a couple. We're going to start with finding horizontal, which means side to side, or vertical, which means up and down, scale factors, using division or multiplication. These are called multiplicative relationships. Multiplicative, and it means that we are either multiplying or dividing. We do not use additive scale factors like plus or minus, and I'll explain why in a minute. So, only using division or multiplication, I'm going to start with horizontal. We can also do vertical. I'm going to show you both ways. Finding a horizontal scale factor means I'm looking for a relationship, a side-to-side relationship between numbers. Probably between numbers from a full ratio, where I have all my information, and looking for that relationship with the number that I do have in my missing column. Columns go up and down. So I could go from 12 to 4 and find a relationship. I could go from 8 to 4 and find a relationship. From 40 to 4 and find a relationship. Notice that I'm starting at the full ratios that have both their puppies and kittens, and I'm always going towards the ratio that I don't know all the information for. So let's say, I think for me the easiest one I see is I know a relationship between 8 and 4. I know that if I cut 8 in half, that gives me 4. Cutting in half means I'm dividing by 2. So a couple things I want you to look at here. Notice I started my arrow at the 8, and I have it pointing at the 4. That means I'm starting with 8. I have to do something to 8, either dividing or multiplying, to make it equal to 4. I always want my arrows to be pointing in the direction of the ratio that I don't have all the information for. So 8 divided by 2 equals 4, which means that my arrow has to go in the same direction, from the same ratio, and use the same scale factor. So I'm going to divide by 2. 2 divided by 2 is 1, so my missing number right here must be 1. Now, let's try a vertical one. Vertical means going up and down. I could look for relationships that go up and down between 40 and 10, between 8 and 2, between 3 and 12. I'm starting with my fully formed ratios because I want to figure out what the relationship I see is. Well, let's see. I know that I want to be going up, because I'm going to start with 4, do something to 4, and make it equal that number. So all of these relationships have to start with my kittens, my bottom number, and go to puppies. What relationship do I see between 40 and 10? Well, 40 is bigger than 10, so I'm probably going to be dividing. 40 divided by 4 equals 10. Notice it's going to be the same relationship for all of them. 8 divided by 4 equals 2. 12 divided by 4 equals 3. 4 divided by 4 equals 1. So check it out. That was the same problem, and I was able to get the same answer, that my missing information is 1, both doing it horizontally and doing it vertically. So it doesn't matter which one you choose. It's just a matter of what relationships do you see. If you saw 8 divided by 2 equals 4, then you could solve this with a horizontal scale factor. If you saw 12 divided by 4 equals 3, then you could solve this with a vertical scale factor. It's up to you to choose the one that works for you in that particular table. Now I'm just going to show you another one real quick right here, where my missing number is on the bottom. I cannot have a scale factor that goes up because I don't know what I'm starting with here. Start with some mystery number, do something to it, and it's going to equal 2. It is easier for me to start with the numbers that I do know and end up with my mystery numbers. So, just so you are aware, you're always going towards your mystery numbers, and vertical can mean starting at the bottom of the table and going up, or it can mean starting at the top of the table and going down. It just depends on your particular problem. So here, if I was looking for a different vertical scale factor, I could say, oh, I know that 1 times 4 equals 4, 2 times 4 equals 8. Now, none of these mystery numbers are really that shocking because I'm using the same number for all of my examples. But you can see that going up, I was dividing by 4, and going down, I'm doing the inverse operation. I'm multiplying by 4. 4 is my scale factor, and my times are divided by, just depends on which direction I'm going. Last one I'll show you for horizontal and vertical scale factors. I don't need to go just from the right to the left. I can also go from the left to the right. I could see a relationship and say, oh hey, 4 times 2 is 8, so 1 times 2 is 2. So I could fill in my missing information that way. Now, I showed you in this example that the scale factor was the same all the way across. That will work for puppies to kittens, but the scale factor would not necessarily be the same all the way across if I chose a different starting point other than 1/4. Because if I started at 40 and went to 8 times 2, 40 times 2 is 80, that's not going to get me my correct answer. This one would be divided by 5. 10 divided by 5 equals 2. So when we're looking at a vertical relationship, our scale factor will be the same between puppies and kittens in every column of our table. When we're looking at horizontal relationships, our scale factors are going to be different from one column to the next because we're looking at different ratios. They are all going to be equivalent because they all have a simplified ratio of 1/4, and they all have that same scale factor vertically. But I just wanted to make that point that while we have the same scale factor, if we go up and down vertically, each scale factor is going to be different going horizontally side to side depending on where you started. Let's try another example. What if you're given this table, notice I took some parts out of it, and you really don't see a scale factor. Let's pretend that you're just, oh my gosh, you're looking at all those numbers and like, how am I going to find something that I can multiply or divide to get up to 40? Well, one other strategy is, if it's not already there, you can simplify any of these ratios to its most simple form. In this case, it's going to be a unit rate. Not always will it be a unit rate with a 1 in it, but you can definitely simplify it down to the simplest form. And that can work with any of the ratios that you're given. Let's say I want to work with 3/12. 3 and 12 share a greatest common factor of 3. I could divide them both by 3. 3 divided by 3 is 1. There's nothing saying that you can't add more columns to your table to help you figure things out. So I added an extra one here. I'm going to fill in, well, I know that 3 divided by 3 is 1, and 12 divided by 3 is 4. This is my simplest form of my ratio, and then from there you can scale up to anything else. Especially if it's a unit rate, you could say, well, I know that 4 times 10 equals 40, so 1 times 10 is going to be my missing number of 10, and that works in here as well. So if you wanted to add on at the end, you can always keep adding columns to your table if you need to figure out more information to help you solve for that missing part. Last strategy. You cannot have additive scale factors. That means these numbers here, the scale factors have to be times or divided by. Those are multiplicative scale factors. But you can add fully formed ratios. So why can you use adding and subtracting in one place but not the other? Let me show you an example. I'll switch colors. If you used an additive scale factor, you said, ooh, 3 and 1, I see a relationship there. If you subtract 2, 3 minus 2 is 1. That's totally true, but it's not true for the other part of your ratios, for the kittens here. 12 minus 2 does not equal 4. So we cannot find an additive scale factor that will work for both parts of your ratio, the puppies and the kittens. However, we can add or subtract two fully formed ratios. Here I have 3 puppies for every 12 kittens. I have all the information in that one. I have 1 puppy for every 4 kittens. I have all the information in that ratio too. I can use these two fully formed ratios to help me solve for a third ratio that's missing some information. And I can use adding and subtracting there. So I could say, I know that 12 minus 4 equals 8. Okay, then I can subtract my puppies as well. 3 minus 1 equals 2. This works because we're not subtracting by a scale factor. We are subtracting or adding two separate fully formed ratios. So do you see the difference there? This was a scale factor. This was using two ratios that already exist. I'm not adding new numbers. I'm just adding or subtracting two fully formed ratios to help me solve for a missing part of another ratio. Our last key points, multiplicative, those are times or divided by scale factors, can be used to find equivalent ratios and solve for missing quantities. That's what we've been doing with all of our arrows and our scale factors where we multiplied or divided by. Again, additive scale factors, where we add or subtract, don't work, but adding or subtracting two known ratios, that does work. Our last key point is that ratios all simplify to the same value. 3/12 simplifies to 1/4. 1/4 is already simplified as 1/4. 2/8 simplifies to 1/4. 10/40 simplifies to 1/4. A ratio by its nature means that we're representing the same relationship. For every 1 puppy there are 4 kittens, whether we have only 1 puppy or 10 puppies or 1,000,000 puppies. They will all simplify to the same value, the same number. Alright, let's do one last piece of practice. What if you get a table with a ton of missing information? Here we have the infant room at Kids Unlimited Daycare. We know there must be 1 teacher for every 4 infants, 4 babies. We have to complete this table. Oh my gosh. Alright, so we have a couple options. Number 1 is we could go vertical. I could say, I'm going to start at the bottom at the 4 because I know a lot of my missing information is up top. 4 divided by 4 is 1. 12 divided by 4 is 3. 16 divided by 4, oh, well, my missing information there, 16 divided by 4, this must be 4. 28 divided by 4 is 7. So you can fill it out that way. Or you can go horizontally and say, I'm going to start with 1/4. I know that 4 times 6 is 24. So I'm going to say 1 times 6, that gives me 6. Notice that your tables don't have to go in order. This goes 1, 3, 4, 7, 6. That's fine. They don't have to go 1, 3, 4, 6, 7 because you're getting bigger. You can have some bigger numbers, some smaller numbers. The order doesn't matter in a table. You could say 4 times 10 is 40. 1 times 10 is 10. Notice it gets a little messy when you do all your scale factor arrows. So you want to give yourself space, actually write it out, and keep yourself organized. And let's say, 4 times what equals 64? I can't really think of that off the top of my head. I don't have to use the same strategy all the way through. I could say, well, I can divide that by 4. Divide by 4. And even if I can't do that in my head, I can take that out to the side and say 4 goes into 6 one time, with 2 left over. 4 goes into 24 6 times. Oh, my last number must be 16. That's how you can fill in the missing information from a table. We're going to skip this question, and you can go on to your student practice and prove your table knowledge now.